In New York, a construction crane comes crashing down onto a landmark bridge.
There was enough dynamic energy released that the entire crane essentially fell on its back.
Tragedy strikes a Titanic TV tower in Texas.
Oh my God!
That scared me to death, because we can't outrun 2,000 feet of tower.
Catastrophe takes out Boston's water supply.
The power of water is immense, and you can see why it was a huge disaster at the time.
And in Sweden, Bruce Springsteen fans nearly bring the house down.
You can see the roof bouncing. It was crazy.
With big builds, even the smallest mistake can be a huge disaster. From miscalculations to misunderstandings, some with deadly consequences. These catastrophes are every engineer's worst nightmare. Big engineering requires colossal machines to get the job done. But if things go wrong, the catastrophe, like the equipment, can be massive. Like this disaster in New York State, on a vital Hudson River crossing.
This humongous crane going across two bridges, it's a frightening experience.
A catastrophic collapse that caught everyone by surprise.
I was in shock. I was not expecting this to happen.
A very lucky escape for both workers and drivers.
A collapse of this nature over an active roadway, this is 1 in a million.
New York City, with over 8 million residents, is the most populated city in the US. The 5 boroughs sit at the mouth of the mighty Hudson River, one of the largest natural harbors on Earth. Adrian Brugger is a professor of civil engineering.
We are a few miles up from New York City on the Hudson River. It has been a powerhouse of transport since the colonial times. This river is really the river that made New York City what it is today.
With so much water to navigate around, bridges are a fact of life.
New York City is carved up by water, and Manhattan alone has 21 crossings, some of them the most famous in the country.
But crossing the Hudson is no easy feat.
What makes this river really unique is that it transects the entire state. This river is actually incredibly wide. It presents a significant challenge when it comes to building bridges.
Since the 1950s, anyone heading over the Hudson north of New York City crossed over this, the near 5-kilometer-long Tappan Zee Bridge. But after 5 decades, it was struggling.
The original Tappan Zee Bridge was built in 1955, when traffic was much lighter. By the turn of the century, around 140,000 vehicles were crossing it every day, and it simply couldn't cope.
The need for a new bridge was recognized for decades. And the main goal was not just to replace an aging structure, but also to increase the capacity.
Opening to traffic in 2018, the epic new Tappan Zee Bridge cost nearly $4 billion. Its twin spans now carry around 50 million vehicles a year.
If you look at the structure, you'll see that it's not really one bridge, it's actually 2 bridges. They're almost identical, but we have 2 spans, one for the eastbound and one for westbound traffic, that are essentially what we call statically independent.
Each bridge has 43 piers, 41 of which are anchored to the bottom of the very wide and very deep river.
The only way to create solid foundations for the huge bridge to carry immense loads was to drive hundreds of steel piles deep into the bedrock.
Driving piles through more than 30 meters of mud and clay, all the way to firm foundations, called for a massive crawler crane with an enormous hammer.
You had this absolutely enormous crane and this vibratory hammer, which is this big block of steel that shakes the entire thing vigorously. They actually use this and the self-weight of that whole system to just push the pile into the mud.
The hammer keeps a tight grip on the pile with what's known as jaw plates. As it vibrates, the whole system works with gravity to drive the pile downwards.
These cranes are serious pieces of hardware. The boom on this thing is almost as tall as the Statue of Liberty, and they're capable of lifting around 300 tons.
Freelance photographer David Rocco wanted to immortalize this mighty construction on film.
It was just fascinating to have this right in your own backyard. I was just out there watching the project day by day, waiting for those moments to get the right shots.
But the most incredible images that David captured would be memorable for all the wrong reasons. Tuesday, July the 19th, 2016, the crawler crane was positioned on the newly constructed westbound span, driving piles for one of the eastbound piers.
The pier would stand on 14 steel piles, 3 feet in diameter, driven deep down into the bedrock.
3 piles had already been successfully placed. Diana Cortez from the Occupational Safety and Health Administration knows the story.
They were in the process of driving the next pile with the vibratory hammer.
During the 4th pile, as they were driving it, it went off plumb. So essentially, it was driving crooked.
The crane operator attempted to lift the pile,
but he was having trouble getting it all the way out of the mud.
Right around noon, disaster struck. With traffic moving in both directions, the massive metal boom crashed down onto the old crossing. David Rocco got word that something was very wrong.
I got a beep from somebody on my cell phone that said crane collapsed on the Tappan Zee Bridge, and I said, oh, wow.
David chartered a helicopter and began capturing the catastrophe on camera.
We shot straight across in the helicopter, got there in less than 10 minutes, and I was going to be on top of it, literally, 1,500 feet above it.
From his bird's eye view, the scale of the devastation was clear.
It's just remarkable to look down there and this humongous crane going across 2 bridges and hanging over the other side. That's a sight I'm never going to forget.
Tons of steel were lying across the bridge with traffic at a complete standstill. OSHA official Diana Cortez was in her office when news of the disaster broke.
when I first heard about the crane collapse, I was in shock. I was like, oh my God. Looking at the boom actually across the road and the traffic jam, the people out of their cars, it was quite a scene. It was actually horrific, to say the least.
Despite the devastation, this disaster had narrowly avoided turning into tragedy.
The boom fell totally across the Tappan Zee Bridge. It didn't hit not one vehicle. So it was a miracle.
A collapse of this nature over an active roadway with no major injuries and no fatalities, this is sort of a 1 in a million. This is actually quite amazing that nobody was hurt.
Even the crane operator, though he probably got the shock of his life, escaped unharmed.
In the immediate aftermath of the disaster, the big question was what had caused this gigantic crane to collapse. Diana Cortez led OSHA's investigation.
As the area director, I immediately sent a team to initiate an investigation, also eventually to make some recommendations to prevent recurrence.
Attention quickly turned to the vibratory hammer, which had successfully driven 3 piles on this pier. But with the 4th pile, things didn't go as planned. After 3 minutes of driving, the pile became stuck at an angle.
Now, what happened at that point in an effort to try to free the pile, instead of just winching up, he actually pushed the boom of the crane up, and the vibratory hammer that was holding onto the pile with essentially a set of jaws ripped free. And this is where things went horribly bad.
This caused the boom to recoil in the upward position, and then when it came down, it caused the boom to structurally fail because of the sudden jolt and collapse and fall right onto the Tappan Zee Bridge.
Investigators needed to determine whether force or failure had caused the hammer to rip loose, so the evidence was salvaged from the riverbed.
After it was pulled back out of the Hudson, they found that the jaws, which looked very much like jaws of, an animal that grabbed the pile, the bearing plate on those, essentially the teeth, was actually a flat bearing plate. This is partially why this jaw ripped loose.
With the teeth corroded closed, the flat back of the bearing plate had been gripping the pile.
The bearing plates secure the vibratory hammer. One of the bearing plates was missing some of its jagged teeth. And also what was found was that the bearing plate was corroded.
Ultimately, the lack of teeth combined with corrosion meant the jaws lost their grip, triggering this catastrophe on one of the state's key bridges. After the disaster, the wreckage was cleared, and just 6 hours later, this vital crossing was partly reopened. Aside from a few buckled railings, neither bridge suffered any real damage.
Of course, this is an enormous crane that collapsed onto this bridge, and the impact was significant and terrifying, but in the end, this is major civil infrastructure that is built for the ages and that is built to absorb gargantuan forces. So even with this crane collapsing on a brand new bridge, the bridge suffered essentially no damage.
The disaster only set the project back a few days, and on September 11, 2018, both spans of the new crossing were fully opened.
This is a lesson that on every project, every piece of equipment needs to be in perfect working order. While it might cost time, ultimately it can prevent catastrophe.
In big engineering, every project brings unique challenges. But even a small change in plan can lead to catastrophe. Like this disaster in Texas, a devastating collapse of a supersized structure.
A TV tower taller than the Empire State Building came crashing down to Earth.
Miscalculations that led to destruction on an epic scale.
People said, okay, we got problems here. It's that last piece that got them.
It took 30 to 40 seconds for the entire tower to fall, which seemed like a lifetime.
The obvious question, what had gone so badly wrong? Houston, Texas has long been one of America's fastest growing cities. In the 70s, oil was driving the boom, and downtown the skyline was soaring too.
Back then, America's favorite pastime was watching TV, and it still is today. But all those huge buildings popping up in downtown Houston were causing havoc on TV and radio signals.
The only solution in true Texas style was to build bigger transmission towers. This site southwest of Houston houses some of the tallest structures in the US, like the Senior Road Tower, standing at a jaw-dropping 600 meters. Former broadcast engineer Bill Cordell oversaw the tower's construction.
Building a structure of this height, 2,000 feet or in that area, comes with real unique challenges in the fact that you have to have special rigging, you have to have special people that know their business. Otherwise, you can get yourself in trouble because those are big boy towers.
Most TV towers are constructed using a tried and true method, the cable and pulley system. hoisting each section before rotating it into place at the top of the tower. Despite reaching higher than nearly every skyscraper on Earth, the tower stands on a base just 45 centimeters wide.
This is the Senior Road Tower base itself. Can you imagine having 982 tons on 18 inches? The amount of compression at this point, you know, as an engineer is staggering. It's staggering. But here it is.
Keeping the tower standing tall demands serious support. Lee Lowry is a senior professor of civil engineering.
After they get a certain height, they can't just stand on their own feet. You have to have some guy wires, some wires holding them in position to the ground.
More than 20 steel guy wires defy the forces of gravity and strong winds to keep the tower standing vertical.
The top guy weighs 10 tons apiece. So you have 3 guy wires that weigh 10 tons that are pulling on the tower just from the sheer weight, and then you tension them. Well, you have to do it very carefully or you'll pull the tower down. In a tower of this magnitude, you have to be very careful.
These towers are extremely vast and highly tensioned pieces of engineering. But they're just the support act. It's all about getting the antenna as high as possible for maximum signal range.
The antenna is like the crown jewel. It has to be built and handled with special care. It's a very pristine thing, a very slow process to get the antenna in place and then test it afterwards.
And crucial to transmitting as far and wide as possible are these, known as microwave baskets.
Those baskets are part of the antenna, and they stick out from the tower pretty far, 2 or 3 feet, that point out towards the horizon.
Microwave baskets send out those all-important signals between the transmitter and the receiver, in this case the tower and your home.
Completed in December 1983, it began broadcasting 9 radio and 3 TV stations to homes across the city. But this is the second tower on this site. Its predecessor met a tragic end. December the 7th, 1982, the final 18-meter-tall antenna section for the original tower was being hoisted into place. Broadcast engineer Bill Cordell asked a colleague to record this crowning achievement.
I had Andy, a good friend of mine and engineer that I've known for many, many years. He was very good at filming. Well, I had him in the back of my truck looking straight up.
5 workers were on the tower to secure the final piece.
It was supposed to be the cherry on top of the cake, so to speak, because once they put the antenna in place and bolted it in, we were practically done.
Instead, with the antenna more than 300 meters up in the air, what Andy captured was the stuff of nightmares.
Oh my God!
Andy never says anything bad. I heard him that day say, "Oh my God." That scared me to death. And you feel very helpless. They were young men that were 1,700 feet in the air, and you knew what was going to happen then.
The falling antenna severed one of the guy wires holding the rest of the tower in place.
The antenna hit the guy wire over here and was sliding down the guy wire. As it slid down the guy wire, it sheared it, and then that's what collapsed the rest of the tower.
As the entire structure came crashing down, workers on the ground scrambled for safety. Bill was just 100 meters away.
My secretary, who was very religious, says to me, "Run." I said, if the good Lord wants us, he's going to take us because we can't outrun 2,000 feet of tower.
3 workers were injured in the disaster, but tragically, the 5 men on the tower all lost their lives.
It took, 30 to 40 seconds for the entire tower to fall, which seemed like a lifetime.
What had caused this supersized structure to come crashing down to Earth? It seems there was a problem with the lifting plan, which had worked for the main tower sections, But with the antenna, there were complications.
The final piece of antenna had those all-important microwave baskets already attached to the sides.
As the antenna was hoisted upright, there was a risk the lifting cables would damage the sensitive microwave baskets. Lee Lowry was on the team that investigated the collapse.
The people said, okay, we got problems here. This great big basket that shoots out all the signals, and the wire to raise the whole piece with it, it's going to hit them.
The baskets were too sensitive to remove. Instead, the team custom-built an attachment to keep the antenna safely at an angle.
The antenna were bolted with what they call U-bolts because they look like the letter U. The cable goes up in the air, and first thing you know, the whole thing starts raising up like this. The extension of this piece of steel far enough down the road so that where you attach the lifting cable will, when it goes up in the air towards the top of the tower, the cable itself doesn't touch the microwave baskets. And it never did.
Hoisting the antenna at an angle prevented the cables from tangling with the microwave baskets. But after examining the wreckage, Lee found evidence that the fix had overloaded the U-bolts.
That's the way I found it. That's where it was. This is a U-bolt. Used to be a U-bolt until it got straightened out by being pulled out of the hole.
Lee and the team calculated that the load on the U-bolts had been underestimated by a factor of 7.
The force that broke the bolt in the first place just pulled the bolt back out of the opposing hole and straightened the U-bolt out pretty much straight. That is the failure. That's the only failure. It's that last piece that got him.
As the antenna was lifted closer and closer to the top, the U-bolts were struggling to cope with the strain and failed. There was nothing anyone could do.
Following the catastrophic collapse, the tower was rebuilt piece by piece. Bill Cordell served as project manager on the new construction.
The second tower, the lifting process was changed quite a bit. And it was extremely well thought out and blessed by professional engineers before anything was done. And of course, none of the rigging or U-bolts that they'd used before was even considered.
A year after the disaster, the new 600-meter tall tower was finally complete. While the team still pays tribute to the young men who sadly lost their lives.
The gentleman that filmed it that day, Andy and I talk each year, and we remember and have a great deal of remiss for the young men that lost their lives here.
With massive infrastructure, even the smallest component is crucial. One tiny fail can cause a huge catastrophe. Like this story in Massachusetts that wiped out a vital water network.
This catastrophe triggered a state of emergency for 2 million people.
People were unable to cook, to drink, to bathe.
An underground mystery that had engineers guessing.
Everyone scratched their heads. That's a new pipe. How could that happen?
Boston, Massachusetts is one of the oldest cities in New England and owes its long existence to the Charles River. Bob Zimmerman is former director of the Charles River Watershed Association.
Water is the single most important substance on Earth for life. All of us are dependent on it. Without it, in 2 to 3 days, most of us die.
Like many big cities, Boston relies on large-scale clean water storage reservoirs located outside of the city limits. Fred Tice is a local journalist.
The metropolitan area of Boston requires a lot of water to keep it going. And in the 1930s, a major reservoir was built called the Quabbin Reservoir. And then another big reservoir, the Wachusett Reservoir.
These two reservoirs combined hold enough water to supply Boston with fresh water for 5 years. But to reach the city, there's a more than 50-kilometer journey from reservoir to tap.
A lot of us take clean running water for granted, but keeping it flowing takes a huge amount of engineering. We just don't see it because it's mostly hidden underground.
In 1996, to stay on top of demand, the Massachusetts Water Resources Authority started work on a brand new pipeline.
The Metro West Water Supply Tunnel is the main tunnel that brings the water from the Quabbin and the Wachusett reservoirs to the Boston metropolitan area.
These pipes are a massive 10 feet in diameter. 250 million gallons of clean water a day can flow through them to 31 towns and cities, including Boston.
These big tunnels supply water to millions of people, and should one of them be cut off, all of a sudden you have a big part of the Boston metropolitan area that finds itself without water.
Hidden from view, the underground aqueduct was a great success. But in 2010, disaster struck. 10 a.m., May the 1st. Fred Lasky, executive director of the state's Water Resources Authority, received a call.
My chief operating officer is unflappable. And when he called, there was a sense of urgency. And then when he explained to me where it was, I said, oh no, oh no.
The Metro West Tunnel had burst open in Weston, more than 20 kilometers from downtown Boston.
When I got here, it was gushing. It looked like the telephone pole nearby was going to go. The whole thing was just eroding, churning up all the dirt, all the dirt, all the dirt.
Boston's clean water supply was surging up from underground.
There were 8 million gallons an hour flowing from this site into the river.
The power of water is immense. And you think about a 120-inch barrel of pipe with water coming towards the city under great pressure, and you can see why it was a huge disaster at the time.
Everybody starts to immediately think, well, it can't be that big a deal, right? It's just a pipe. But it is a big deal. 8 million gallons an hour is, get your attention, amount of water, a real issue.
Not only was clean water pouring out, dirty earth was being sucked into the pipes, potentially contaminating everything heading for Boston.
This was an even bigger problem when we found out that people were unable to cook, to drink, to bathe.
About 2 million residents who had to begin to boil their water for drinking water and get as much bottled water as possible.
The following day, the leak was stopped, but Bostonians were still without clean water.
It's front page in the Boston Globe. It's on the news every single night. Every family east of here who has to boil water or go out and buy bottled water knows about it and is concerned about it.
This was national news. President Obama even signed an emergency disaster declaration.
More than 1 billion liters of water had escaped. The race was on to get to the root of the problem.
Everyone scratched their heads. What happened? How could that be? That's a new pipe. How could that happen?
Well, a 10-year-old aqueduct is brand new. And for it to blow out, something seriously bad happened.
As the debris was cleared, it revealed a small but crucial piece of evidence.
The amazing thing is after all the earth had been moved, there was a pond of water. When we pumped that out and the top of the pipe started to surface, we realized that all that water was coming out in a gap between the pipes all the way around of about 1 inch. And it was just an incredible lesson in the power of water.
The source of the leak was clear, the joint between two sections of pipe. But the question was, why had the connection failed? Dr. Zorica Pantic chaired the investigation.
As a panel, we looked actually at the possible scenarios that caused this failure. The one would be the vertical shear so the pipes moved in the vertical direction. When we looked at the site, we realized that the pipes are still aligned. So that means that the vertical shear was not a possible scenario. So then we focused actually on the coupling and looked what happened with the coupling.
The two pipes were clamped in place with a two-part steel coupling collar, held together with 8 steel studs more than 2 centimeters wide, secured by 16 nuts. As investigators dug deeper, it was clear the collar was buckled completely out of shape.
This huge 1-ton piece of steel clamped 2 sections of pipe together with a vice-like grip. But it had failed catastrophically. The question was why?
Further inspection revealed that 7 of the 8 studs holding the collar together had broken.
So basically, out of 8 studs that were supposed to be there, only 3 were found, and only 1 was still connected to the coupling.
Examining the studs revealed a flaw.
What we found out is that there were cracks in these studs, both in the valleys and on the hills and the tops of this.
Dr. Pantich's team concluded that the cracking had happened during manufacturing. Once installed underground, the studs were vulnerable to corrosion.
When they were installed, they worked for a while until the environment caught up with them. That caused corrosion along these cracks in the studs. And once those expanded, the studs starting to fail and break.
Ultimately, the faulty studs were simply too weak to do their job.
Huge amounts of water were being pumped through these pipes at high pressure. Without a rock-solid connection, the coupling was doomed to fail.
Millions of residents were without mains water, so engineers worked around the clock to repair and flush clean the Metro West pipeline.
We had one group of people working on addressing the leak and fixing it. We had another whole group of smart people who were dealing with the hydraulics and the water quality issues and how do we get it turned back on to make sure it was safe. Because that would have been a real disaster if there was contaminated water.
On May the 4th, just 3 days after the joint failed, the repaired pipeline was back in action.
When clean water was finally restored, it was a huge relief for residents and a reminder of how dependent we all are on the infrastructure hidden beneath our streets.
To avoid a repeat disaster, a parallel pipeline known as the Holtman Aqueduct was upgraded, ensuring there was always a route for clean water to reach Boston.
We are now in a vault chamber that connects the Holtman Aqueduct to the Metro West Tunnel. And this was constructed after the water main break to create the redundancy that we need to safely operate the system in a major event.
This time clamped solidly together by hundreds of studs.
And you can see the massive size and the strength in these couplings.
The events of May 2010 serve as a reminder of the massive task engineers face keeping our vital infrastructure operational.
It was a big wake-up call because we all face issues associated with infrastructure, much of which is getting pretty old at this point. And as it fails, people are impacted. Nature is impacted.
2 lessons to learn from this, right? One is we take water for granted. We just never think about it. We turn on the tap and there it is, and we use as much of it as we want. The other is how critical, just one little point of failure can be.
When engineering goes wrong, the cause can be plain for all to see. But sometimes it's hidden out of sight. Like this story in Sweden, and a Springsteen concert that really rocked the house.
The whole arena started to fall apart.
Music fans almost brought this structure to its knees.
You can see the roof bouncing like a meter or something.
It was very close to a big catastrophe.
But what could nearly take down an entire stadium? Gothenburg, Sweden's second largest city, is home to just over 500,000 people. But for a small city, it has a big music scene.
Say Swedish band, and chances are most of us think of ABBA, who burst out of Stockholm in the 70s. Although less well known, Gothenburg has long been home to a much cooler, edgier music scene.
Johan Lindqvist is a local music reporter.
It's been a music town for many, many years. The music here comes from the underground. We have a lot of metal, hip-hop, reggae music. We have great venues and a lot of vibrant music life.
This is Gothenburg's Near-Ullevi Stadium, named after the Norse god of games and sport. With a capacity of 75,000, the more than 200-meter-long oval is the largest outdoor arena in Scandinavia and has hosted some of the biggest names in music. Lotta Nibel is CEO of the company that runs the Ullevi.
So, this is where the magic happens. And through those doors, you've had rock stars like Madonna, you had Pink, Coldplay. You had loads of famous people walking in and making magic for thousands and thousands of people.
Before the music scene took Gothenburg by storm, the stadium was designed for the Soccer World Cup.
When Ullevi was built, it cost $4 million. The venue was ready to welcome the World Championships in soccer in 1958.
The field is towered over by two 52-meter-tall pylons holding floodlights and helping to support the roof below. The design was unique, but the structure, like many stadiums, was concrete and steel. Professor Göran Kjellfors is a geotechnical engineer.
Ullevi Stadium was designed and built in the 1950s. The main part of Ullevi is made of cast-in-place concrete, and the roof is made of steel beams and lightweight concrete sitting on top of the beams.
This part of Gothenburg sits on clay. It's a great flat surface for a soccer pitch, but the concrete structure of the stadium would need much stronger support.
The solution was a network of piles beneath the seating areas.
Here we see a cross-section of Ullevi with a main structure, cast-in-place concrete. We have the clay layer, we have the moraine, and we have the bedrock. And here are the concrete piles that go all the way down to bedrock, which carries all the loads from the arena.
In the 1980s, Ullevi began hosting concerts, and one of its first acts was Bruce Springsteen.
In '85, Bruce Springsteen was playing 2 nights at Ullevi, and it was his biggest tour up to date. I mean, it was bigger and more popular than ever, selling out big arenas all over the world. So, I mean, there was a kind of hysteria going on, of course.
Stefan Hammerströ was working in the arena at the time.
I was only 18, 19 years working here, so everybody has bought the album Born in the USA, so they knew the songs and they were ready for the concert.
It's like 65,000 people. At that point, that was the biggest crowd at Ullevi for any concert, and I guess there were mostly teenagers there. It was a lot of energy and a lot of jumping up and down.
During the concert, the energy was building up, so it was crazy. We who worked in a kiosk couldn't stand still. You automatically danced in the kiosk.
Towards the end, Bruce played the old classic Twist and Shout.
And people even got more crazy than before, and the whole arena moved like this, 10 centimeters or something. And then you looked up the roof, you can see the roof bouncing like a meter or something when you saw it from here. So yeah, it was rocking out the arena.
Thousands of people jumping to Twist and Shout. The whole arena started to fall apart.
For me it was exciting, but maybe if you think about it after, maybe it was a little bit scary.
The shaking wasn't limited to the stadium. Apartment owners 400 meters away reported ornaments and books falling from their shelves. As the music faded, it became clear that this hadn't been a small shakedown.
After the concert, they had to look at the arena, and they discovered that there were damages done to the structure.
The stadium had previously survived the Rolling Stones, so what had the boss done to cause such trouble? The source of the problem wasn't in the stadium structure itself, but in the ancient ground beneath the soccer field.
Here in the inner field is a lot of clay, and this, when the audience started to jump here, that meant that the clay started to move like this.
Back in the 50s, the pitch, or infield, was built to have 2 football teams and the referee running around on it, not 20,000 plus excited fans jumping up and down.
All that jumping wasn't just pounding the floor. It was also rocking the stadium and its towers.
So the force from the audience goes into the clay. The clay expands like a pulse, and that affects the piles. So they bend out a little, not very much, a couple of centimeters perhaps, but that will give deformation that then will be transmitted up to the structure and enlarged. So it's a rhythmic pulse coming up also into the structure.
We've all felt the pulses of heavy bass from loud music. Imagine that happening to the clay beneath the pitch over and over, pushing on the piles supporting the stadium and its towers.
The pulses weren't the only problem. The frequency of the jumping matched the clay's natural resonance.
Experts calculated the resonance of the clay was between 1.5 and 3 hertz, or cycles per second. The music and the jumping of the crowd was 2.4 hertz, right in the sweet spot for causing mayhem.
That is close to the resonance frequency of the clay, and then there is no damping, and that's why it's enlarged, and it's going to increase all the time as the pulse keeps going on.
Although fans didn't realize it at the time, the stands were dangerously close to collapse.
Now here we see the concrete structure, and between those constructions there are beams, concrete beams, and they are supported like this. And this is probably about 20 centimeters or so. And during the concert, these started to move up and down and also sideways. And in the inspection after the concert, they found out that the support was very limited and it was very close to a big catastrophe.
These days, everyone jokes about the crowd nearly bringing the stadium down. But the truth is, here, they came frighteningly close to actually doing it.
Ullevi Stadium closed its doors while engineers resolved its structural integrity. Although the building itself was fine, the field needed support to prevent it from bouncing.
Well, the stadium had to be reinforced using over 100 pillars, each having a diameter of 1.5 meters and a length between 20 and 60 meters, because you need to reach solid ground. And as a result, you can see it in the garage. You can actually see the pillars and the size of them.
The network of piles was driven down into the bedrock. Thomas Tayland is Ullevi's construction project manager.
Now we are under the pitch. Here you see it from below, the roof in the garage. And over here you can see every 15 meters you can see the piles. Every one of these piles, they had to stand on the rock. So it's a big job, a lot of concrete.
Once the piles were driven into the bedrock, they were like a network of giant stilts supporting the pitch above. Now, however hard fans jump, the clay below and the stadium won't be going anywhere.
3 decades after that dramatic night, Springsteen returned to the Ullevi.
Are you ready to test this stadium?
And proved the fix really had worked.
This time, the only thing rocking was the music.